In this video, we will calculate arc length and sector area in radians. If you have the central angle given in radians, the arc length is equal to the radius times the central angle. It's the simplest thing in the world. So for this problem, we are supposed to calculate the length of the arc, and they gave us the radius and the central angle in radians. So it's just going to be r theta. So that's just going to be 12 times 3 pi over 4. Now, 4 goes into 12 3 times, so that's going to be 9 pi centimeters. Okay, that's it for number 22. Now, on the other hand, if you want to find the area of this arc, again, the central angle needs to be in radians, but the area of the, did I say arc? The area of the sector is going to be 1/2 r squared theta if the central angle is in radians. Okay, so find the area of the sector if the central angle is 3 pi over 4 radians and the radius is 12 centimeters. So again, the area is going to be 1/2 r squared theta. So in this case, that's going to be 1/2 12 squared times 3 pi over 4. So that's 1/2 144 times 3 pi over 4. Half of 144 is 72. Four goes into 72 evenly. Alright, if you do 72 divided by 4, you wind up with 18. So that just leaves you with 18 times 3 pi, which is 54 pi. Alright, so 54 pi centimeters. Sorry, we're talking about area, so centimeters squared. Let's look at number 24. The Parks Department is thinking of constructing skateboarding ramps in some of the local playgrounds. A half-pipe ramp is formed by 2 quarter-circle ramps, each of which is 10 feet high, plus a flat space of 20 feet between the centers. Find the exact distance a skater travels from the top of one ramp to the top of another ramp. So basically, we're talking about 3 distances that we're going to add up. A skater will travel from the top of one ramp to the top of another ramp, but the skater will travel through this curved distance and this curved distance. Alright, those are arc lengths. And of course, in between, the skater will travel this flat path. Alright, so we really are finding the sum of those 3 distances. Now, the flat distances is 20. So that's no big deal. So the trick is to calculate the arc length of these 2 arcs. And they're identical, so we can just find one of them and double it. So let's call this S and find it. So the arc length is going to be r times theta, as long as theta is in radians. So the radius is 10 feet, as you can see in the picture. Okay, now as far as the radians, this is a quarter of the circle, So this is half of pi. This is pi over 2. Okay, I mean, remember, like if we were talking about the unit circle, this would be pi, but then right here would be pi over 2. It's the same thing. This is 1/4 of the circle. A 90-degree angle is pi over 2. Okay, so that's it. The arc length then, 2 goes into 10 5 times, so this is 5 pi. Alright, 5 pi feet. So each of these are 5 pi. Okay, so this quarter arc over here is 5 pi, and this quarter arc over here is also 5 pi. So if we add this all together, 5 pi plus another 5 pi, of course, is 10 pi. So we're dealing with 10 pi plus 20 feet. And that's the best we can do while staying exact as requested. All right, 10 pi plus 20 feet.